Hello, I am Rishikesh. Welcome back for learning the AWS Cloud Practitioner. So our today's topic is scalability and high availability. Scalability and high availability are two critical principles in cloud architecture. Scalability is the ability of a system to handle increased workload by adding more resource, while high availability focus on ensuring that application remains accessible and resilient even in the face of a failure. In AWS, scalability allow you to grow your application dynamically as a traffic increases, and high availability ensure that your services are distributed across multiple availability zone to minimize downtime. Together they enable businesses to deliver reliable responsive and resilient services at scale. Key point: scalability, growing resource to meet demand. High availability ensure uptime despite failure. AWS provide both via EC2 autoscale and load balancing. Vertical scalability meaning increasing the capacity of a single server or instance by upgrading CPU, RAM, and storage. In EC2, this means stopping an instance and relaunching it with a large instance type. It is simple to implement but limited by hardware constraints. Scaling is often used in database and legacy application where multi-server architecture is not possible. Point: scales by upgrading instance size. Good for a monolithic app or database. Limited by hardware maximums. Require downtime uh, to resign in EC2. Horizontal scalability. Horizontal scalability means adding or removing multiple instances to distribute workload in EC2. This is implemented using auto-scaling group which automatically launch or terminate instance based on demand. This approach is more flexible and fault tolerant because workload are distributed. Horizontal scaling is common in a modern microservices web applications and cloud native environments. Point: add remote multiple servers dynamically implements via auto scaling in EC2, more resilient than vertical scaling, ideal for web API and microservices app. High availability ensure that application remain accessible with minimized downtime in AWS. This is achieved by developer resource access multiple availability zones AGS. For example, an application hosted in multiple AGS with an elastic load balancer can continue running even if one AGS fails. HA require redundancy, frequent tolerant design, and often automated recovery mechanism. Points: minimize downtime and services interrupts. Use a multi-AZ development for a resilience. Load balancing ensure continuing during failure. Redundancy is a foundation of HA. High availability scalability for EC2. For EC2, AWS combined auto-scaling group and elastic load balancer to deliver both scalability and high availability. Auto-scaling ensures instance increase or decrease automatically depending on demand, while load balancer distribute traffic across healthy instance in multiple AGS. This architecture not only keeps application high availability during failure but also optimize the cost and performance. Points: autoscaling scales EC2 up or down. Elastic load balance distribute traffic. Multi-AZ or development ensure HA during outstage, and together resilient plus cost effective apps. Scaling versus elastics. Scaling is the availability to grow resource to handle increased demand. Elastic is the availability to automatically scale resource up and down in real time as demand fluctuates. Elasticity is what makes AWS cost effective. Agility refer to how quickly organized can deploy Points: scalability, ability to grow resources, elasticity, auto adjusting resource in out, agility, speed to innovative and adaptive. Adapt. What is load balancing? Load balancing is the process of distributing incoming application traffic across multiple service servers to ensure no single resource is overloaded. This improves performance, increases reliability, and prevent downtime. In traditional IT, it's required dedicated hardware application, but in AWS, load balancing is fully managed and scalable. Point: distributed traffics evenly improve fault tolerant and performance, prevent overload and single instance. Foundation for HAX architecture. Why use a load balancer? A load balancer ensure that applications are not depend on single EC2 instance. If one instance failed, the load balancer redirect traffic to healthy instance, ensure continuous service. It also support SSL, terminational health check, and cross-zone load balancing. Overall, it increases fault tolerant and optimize resource on utilizations. Point: fault tolerance rerouted to health instance, better performance throughout even distribution, support monitoring with health check, enable seamless scaling with auto scaling. Why use elastic load balancer? Elastic load balancer is AWS managing load balancing service. It automatically distribute traffic across multiple target in multiple availability zones. Unlike traditional load balancer, ELB scalers with demands and require no manual maintenance. It integrates with auto scaling and provides additional features such as SSL termination, codes, sticky seasons, and integration with AWS AF for security. Points: fully managed AWS service, scales automatically with the demand, work across multiple AGS, support HTTP, TCP, UDP, and gRPC, integrate with the auto scaling WAF cloud watches. Thank you so much for this video.